This video deals with the interfacing of LCD with 8051 microcontroller. First, let's see the advantages of LCD. LCD has got the ability to display numbers, characters and graphics. Ease of programming for characters and graphics. Due to the declining prices of LCD, it has got a widespread use all over the world. Then let's see LCD pin descriptions. Pin number 1 VSS ground. Pin number 2 VCC used for connecting plus 5 volt power supply. 3 VEE used for controlling contrast to LCD. Pin number 4 RS select command or data register. If RS is equal to 0, command code register is selected. If RS is equal to 1, data register is selected, allowing the user to send data to be displayed on the LCD. Then, pin number 5 R bar W. R bar W means read bar write operation. If R bar W is equal to 1, reading operation is executed and R bar W is equal to 0, writing operation can be done. Then pin number 6 E. E means enable. The enable pin is used by the LCD to latch information presented to its data pins. When data is applied to data pins, a high to low pulse, that means 1 to 0 pulse, must be applied to this pin in order for the LCD to latch the data present to the data pins. So, E is an important pin for LCD. Then pin number 7 to pin number 14 are data bus pins, DB0 to DB7. 8-bit data bus pins. The 8-bit data pins DB0 to DB7 are used by LCD to send information to the LCD or read the contents of LCD's internal registers. Next is LCD command codes. If you are writing 1, it means that clear display screen. You have to study these LCD command codes in order to program LCD. Otherwise, you can't program LCD. Pin number 2 deals with the return home. 4 decrement cursor, 6 increment cursor, 5 shift display right, 7 shift display left, 8 display of cursor off, A display of cursor on, C display on cursor off, E and F same display on cursor blinking, 10 shift cursor position to left, 14 cursor position to right, 18 shift the entire display to left, 1C shift the entire display to right, 80 force the cursor to the beginning of first line, C0 force cursor to the beginning of second line, 38 2 lines 5 into 7 matrix LCD is initialized. Now, LCD interfacing with 8051 microcontroller. As I have already told you, RS means register select, which is used to select command or data which is connected to P2.0. Then R bar W read bar write operation connected to P2.1. E enable pin connected to P2.2. Then data bus pins D0 to D7 connected directly to P1.0 to P1.7 pins. Since these port 1 pins have no dual function, it can only act as input-output pins. So, we have connected D0 to D7 pins to P1.0 to P1.7. Then, as you all know, VCC means power supply, which is connected to plus 5 volt. VEE, which is used for controlling contrast in LCD. So, it is connected to a variable resistor, 10K resistor. Then VSS connected to ground. Now we can see a program for displaying NO. First org 0000H, then move a comma #38. What is the meaning of 38? 38 means 2 lines 5 into 7 matrix LCD is initialized. Since this 38 is a command code, I have called a call C1. So, C1 means command code instructions can be executed here. So, I have shifted this accumulated data, that is this 38H to port 1, since we have connected D0 to D7 pins to P1.0 to P1.7. So, accumulated data is transferred to port 1. Then I have cleared P2.0 pin. Then P2.0 is connected to register select. If P2.0 pin is equal to 0 means command code is selected. So, this 38 is a command, so I have cleared P2.0 pin. Then I want to write something to LCD. I want to write the data NO to LCD. So I want to get P2.1 pin to be cleared. P2.1 is connected to read bar write pins, read bar write command. If R bar W is equal to 1 means reading operation can be performed. If R bar W is equal to 0 means writing operation can be done. So, here I have cleared P2.1 pin in order to write. Then P2.2 pin is connected to enable. That means high to low pulse must be applied to this pin in order for the LCD to latch the data present in the data pins. So, first I have put set B P2.2 making enable pin as I. Then a small delay is called. Then CLR P2.2 making enable pin as low. Then I have returned to the program where I have interrupted. Then a call del. Del means here. Delay has been called. Move R3 comma hash 50. R3 will be having the value 50. Move R4 comma hash 254. Right? R4 will be having the value 255. DJNZ R4 here means this 255 becomes 254, 253 and so on until it becomes 0. It will be looping here. Then after it becomes 0, DJNZ R3 here too. That means 50 becomes 49. Then again this R4 will be having the value 255. Again 255 becomes 0. This instruction will be executed. So, these instructions will be executed until this R3 becomes 0. That means it will be executed 50 times. 255 becomes 0 will be executed 50 times. So, a delay will be created here. So, after return, I will be again going here. Then move a comma hash 0E. What is the meaning of 0E? After initialization, I have switch on my display cursor blinking. 0E means display on cursor blinking. Then again it is a command, so I have called a call C1. Then for creating a short delay, I have called a call DL. Then after this cursor on, move a comma hash 01. 01 means I have to clear my display screen. So, for this instruction to be executed, again a command. So, a call C1, a call delay is called. Then move a comma hash 06. 06 means shift the cursor to the right position. So, this is also a command. So, we have again written a call C1, a call del. So, C1 instructions will be executed, DL instructions will be executed. After that, it will be executing move a comma hash 84H. What is the meaning of 84? 80 means force cursor to the beginning of first line. 81 means force cursor to the beginning of first line first position. 82 first line second position. 83 first line third position. 84 first line fourth position. So, this NO will be displayed in first line fourth position. So, this is also a command. So, I have got a call C1, a call delay. So, before writing any data to the LCD, we must check the busy flag. This I have forgotten to tell. before writing any data to the LCD, we must check the busy flag. If read bar write operation is equal to 1, that is reading operation is performed, and RS is equal to 0. RS is equal to 0 means command code register is selected, and D7 bit is equal to 1, indicating that this LCD is busy taking care of some internal operations and it will not be accepting any new information. So, when D7 is equal to 0 indicates that LCD is ready to receive any new information. So, before writing any data to the LCD, we must check the busy flag. After that only we can write this program. So, here first 5 into 7 matrix, 2 lines, LCD is initialized. Then I have switch on my display and cursor blink. Then I have cleared my display screen. Then I have shift my cursor to the right position. Then I have forced the cursor to the beginning of first line, fourth position. After this, I can write my data. Move a comma hash n. Here n means it is a data, not a command. So I have called a call data. So it will be going here. Only difference in this is that move p1 comma a accumulator content, that is that n is transferred to port 1. Then since it is a data, I have to make this p2.0 pin as 1. Because register select pin means command.data is selected. If it is 0, command is selected, and if it is 1, data is executed. So, by making set b p2.0, data can be executed here. Then same instruction CLR p2.1, I have to write data. So, p2.1 have to be cleared. Then I2 low pulse has to be latched into the pins, enable pins. So, first I have make p2.2 as 1, then I have cleared p2.2. Then again return to the my program. Here I have written move a comma hash o. Again it is a data. So, these data instructions will be executed. Then S jump, again short jump will be carried out here. Then the program will be end. This I have created by using Keel and Proteus software. Program is written in Keel software, and this LCD and 8051 is drawn using Proteus software, and after this program is burned here, and result NO is displayed in my LCD screen. I have gone through LCD interfacing. First I have discussed about the pin descriptions, then I have gone through command codes, then I have gone through the connection of LCD with 8051. Then after that I have also explained about the program and how this result as displayed in my LCD. Hope you have understood this video. Thank you.